arithmetic series. An arithmetic series is the sum of the terms of an arithmetic sequence. So now we can find the sum of a finite arithmetic series, right? The ones that end, we can find the sum of those. The ones that don't end, we can't. Those are divergent. So the way you find the sum of a finite arithmetic series is this way. So if you want to find the sum of the first n terms, you can use this formula where you have the sum of the first n terms of an arithmetic sequence is n over 2 u1 plus un. So u1 is the first term, un is the mth term. That's going to watch out. That's not the n, that's the mth term. Very different things right there. Or you do this formula, which is my favorite. N over 2 times the first term plus n minus 1 times d. So again, n and n, same things right here. And the common difference. So look at the first question here. Find the sum of this arithmetic sequence. So it's an arithmetic sequence. If you look at it, we're adding 7 each time. So it makes an arithmetic sequence. We're going to do that the first 50 terms. So we have two formulas here. You can use either one we want. Now, if I'm using this formula, what I do not have is a 50th term. I do have the first term, but I don't have un. I have n, and it's 50, but I do not have the last term. I can figure out the last term. I could, and then I can use this formula. Or you can just use this formula already from the go. Right? All you need is the number of terms, 50, the first term, u1, 4, and then n, 50, and then the common difference, 3. So this is why I prefer to use this formula most of the time, because you don't need the last term. A lot of times they don't give you the last term, so I tend to use this formula. You know, it looks longer. So I want the sum of the first 50 terms, which is 50 over 2, because that's n, 2 times u1, which is 4, plus n, 50, minus 1, times the common difference, which is 3. So like that. Now keep in mind, if you're doing this is parentheses, so I'm going to do this first, and I'm going to times it by 3, and then I'm going to add it to this guy. A lot of times people they drop the parentheses, and they start multiplying this out to all the thing first. Like, don't do that. So it's 25, then inside the parentheses is 8 plus 49 times 3. Now again, I have to do this first, or operations, multiplication before addition, so I have to do these two first, and then I can add it to 8. 49 times 3 is, let's see, 50... It's 147 plus 8, so I'm going to get 25 times 155, which I don't know what that is. So I can use the calculator real quick. I get 3875. So there we go. Next one, find the sum of negative 6 plus 1 plus 8 plus 15 all the way to 141. Now I know what you're saying, like, wait, whoa. Hey, now I can use the other formula. N over 2 u1 plus un, because I actually do have un. That is true. This is your un. And you have your u1. Very good. We're actually missing something. No matter what formula we're going to use, we're actually missing something. That is n. I don't know how many terms this is. So here's my general rule. If you're missing something, plug in what you have, sub in what you have, into the general formula, which is this guy. Right, so I'm missing, I have u1, that should be u1 up here. I have u1, I have un, I don't have n. And even if I would use the other formula, it would be the same problem. If I was using this formula, I would have u1, I would have the common difference d, I wouldn't have n either way though. So in this case, I'm going to use the easier one. But anytime you're missing something, in this case I'm missing n, you plug in what you have into the general formula. So this is our general formula, right? What do we need here? We need u1, which I have is negative 6. I need the common difference, which I could find out. So let's see, we're adding what, 7 each time? I don't have my n, but I do have a un, right? Un is 141. So anytime, how that switch? Anytime you're missing something, just go back to the basic formula and plug in what you have, and then you can find out what you need. So we have this. I'm going to solve this real quickly. Let's see, I'm going to add 6 to both sides. I get 147 equals n minus 1 times 7. So in this case, you could either distribute the 7 and then move over, or you could just divide by 7. So what, 21 equals n minus 1, right? Because 14 divided by 7 is 2, 7 divided by 7 is 1, and then add 1 to both sides. So we get n equals 22. So now I have my n, and once I have that, I can go back and plug that into my generic formula up here. Right, so this is s of n. So now we could plug that all into our formula up here. So this is 22, sorry. That's 22. My u1 is -6, and my un is 141. So we have this. So that makes this 11. Let's see, what's 135? Now this one I don't need a calculator for. That's 135 times 135. All the way around. There's little shortcuts at adding this. So I get 1,485. That's the sum of the first 22 terms. So the key thing there, right? Anytime you're missing a certain term, you're missing an n, you're missing your u1, anything you're missing, always go back to the general formula and plug in what you have so you can find the thing that you're missing. Then you can do it. That would have been true up here also, by the way. If I really want to use this formula, I could go back to my original formula, the original term, right, and plug in what I had to find un, because again, I don't have un here. So u1 I would have 4, n I would have 50, common difference I had is 3. So you can simplify that and get your un, and then you can use this formula if you prefer. Sorry about that. I usually moved that down earlier. Next example. An arithmetic sequence has the first term 8 and a common difference of 2. The sum of the terms of the sequence is 170. Find the number of terms in the sequence. So what are they telling us? The first term is 8. Common difference is 2. The sum of the sequence is 170. Find the number of terms in the sequence. So they want us to find n. Now look what I have here. What formula could I use, right? We have two formulas. One of them has a common difference, and so that we probably have to use that formula, which is a longer one I like. N over 2. Again, this is all in the formula sheet. You don't need to memorize it. U1 plus n minus 1 times d. So that's our formula we have to use because it has a common difference. And all we have to do is figure out what n is. Plug in what we know. So they gave us un is 170. Sn is 170, sorry. U1 is 8, and the common difference is 2. And let's do some math. 170 equals n over 2, 16 plus n minus 1 times 2. Let's distribute. So I get 2n minus 2. So I get 170 equals n over 2, 16, let's say I could simplify that already. Right, add like terms, 16 plus -2 is 14. 2n plus 14. Now before I simplify this more, I want to get rid of this fraction. We don't like fractions. So let's multiply both sides by 2. Right, so these would cancel out, and I get 340, 0, 14. Yeah, 340, I don't know why I paused. And then I get n, 2n plus 14. Now this is a math problem. Distribute. 340 equals 2n squared plus 14n. Now, I can set this equal to 0 and solve, but look how ugly that's going to be. Honestly, the way to do this, I'm going to use our calculator. Right, because that's going to be ugly to fact. It'll be that bad? Maybe it's still going to be kind of ugly. Let's do y1, y2. So 340, and then this is going to be 2x squared. I feel like I'm being lazy by doing this. Plus 14x. So I could divide everything by 2, make it a little bit nicer, but I still think it's going to be kind of ugly. Now, I'm going to figure out the graph right now. Keep in mind, notice my y1 right here is 340. So I'm going to change my 1 up from the very start and make that like 400. So I could see it. So, right, I made all the way 400 so I actually see the 340. And then here's the graph. Look, it barely crosses. Let me expand my y. I want to be able to see everything. So let's go from like -40 to 40 or something. So I could really see where it's crossing. So there we have two x-intercepts, and I want to talk about those two intersections right there. So second, calculate intersect. So let's find this one first, I guess. Enter, enter, enter. Now remember, when I graph it, if you're solving by graph, I like to see the actual graph. It doesn't have to be perfect. This is a sketch. I know what's going on. So this is 10. Makes me feel worse about skipping this. Second, calculator intersect. I feel like I'm just being super lazy. I'm going to find the other guy. Let's go a little faster we do this, but by hand it's a little faster to do this. On a calculator it's actually worse. -17. Now the reason I want to show you both answers is because remember we're finding n should always be a positive integer, so it should be like a natural number, right? It should be one of these guys. So it can't be negative. You can't have a negative term of sequence. So this is not the answer. So it's just 10. So n equals 10. So keep that in mind when we're doing sequence and series. We should never have a negative term. They're always positive. They're always natural numbers. Next one. The sixth term of an arithmetic sequence is 21. The sum of the first 17 terms is 0. Find the first two terms of the sequence. So again, let's write down what they want us to find. So the sixth term of the arithmetic sequence is 21. So that means U6 equals 21. The sum of the first 17 terms, so that's S17 equals 0. Find the first two terms of the sequence. I want to find U1. I want to find U2. So we have this and we have that. Now what I will do here is do what we always do. If we're not sure about things, let's go back and plug into the original formula. So UN equals U1 plus n minus 1 times d. And honestly with this one, I'll probably do the same thing. Now what formula do I pick here? You want to pick ones that have like variables. So this variable here has a d, it has the common difference d. So we want to use a formula here that has a common difference that's the same. So we'll use my favorite one. Because what's probably going to happen here is two equations, two unknowns. So I'll make sure you have the same variables in both of them. So remember the way we substitute this in? 6's are in. And then when you plug in 6, remember the way this really means is when you plug in 6, you get 21. So all of this is 21. So this is 21 equals U1 plus 5D. So as far as I go there. On this side, now this happens here, when you plug in 17 for n, you get 0. So this would be 17. That would be 17, and we get a 0 on this side. So you have 17 over 2, 2U1 plus 16D. Right, okay. So, we've been here before. We have two equations, two unknowns. We have a U1 and a D and a U1 and a D. So we're going to solve this by elimination or substitution. Any way you want to do it. Doesn't matter. Now before I do that, let's make this side a little bit more palatable. Let's get rid of that fraction. So we'll multiply everything by 2. And we get 0 equals 17 2U1 plus 16D. Now, it's still a 0 on that side. I could divide by 17. I just could get this all by itself. So let's divide by 17. So I get 0 equals 2U1 plus 16D. Right, that made life a lot easier. So we have this and we have this. So two equations, two unknowns. Again, you can do substitution, elimination, anything you want to do. I'm a big fan of elimination when I have it like this, but you can easily do substitution. Like solve for U1, which would be 21 minus 5D. Plug it in for U1 and solve that way. But again, like I said, I'm a sucker for elimination, so I'm going to do this. Let's put them right next to each other. Honestly, in this case, substitution is probably the best. U1 equals 21 minus 5D. Right, so that's what U1 is. Since U1 is by itself, substitution is probably the best way of doing it. So I'm going to subtract off the 5D. So I have this. We're going to plug this in for U1 over here. So it's going to be 0 equals 2 times this guy, 21 minus 5D, plus 16D. Distribute. 0 equals 42 minus 10D, plus 16D. Add up like terms. 0 equals 42 plus 6D. So now we just solve. Negative 42 equals 6D. Let's divide by 6. D equals negative 7. So that's my common difference. Now again, I'm not done yet. I do got to find U1. So you can plug it back into any formula you want. Remember, the benefit about doing substitution is you can plug it back into this formula. Right here. So 21 minus 5 times negative 7, I think I had. Yeah. So it becomes 21 plus 35, which is 56. So U1's 56. And then my common difference is negative 7. Now let's go back to what the question was. Find the first two terms of the sequence. So I actually found the first term. U1 is 56. Now how do we find the second term? I can set up a whole equation and plug it in, but we don't need to. The common difference is negative 7. So all I got to do is subtract 7. So I get 49. So you're looking for. right? If I want to find the third term, just subtract 7 again. That's what the common difference does. You just keep on subtracting until you get what you want. Anyway, those are the first two terms, and I believe that's the end of this lesson.